For the past couple of days, I have been working on lane detection. Over here we can see a video wherein there's a driver who is driving down the road in the middle of the evening, late afternoon, early evening, and you can see we have two lines indicating where the two boundaries of the lane are, red for the left and green for the right. So I shall now take you through how I made this work. The libraries used in this code are NumPy, matplotlib for finding out exactly where we're going to draw or crop out our image, CV2 for all the most of the image handling, and time for getting a unique file name. Before we get into the details of how all the functions work specifically, we first need to get a general overview of how they all fit together. So first of all, we have to import the video or open it and treat every frame as if it was a singular picture that we were performing all the functions on. We also will be writing out our resulting video with the lane lines overlaid onto it. That is what the out variable will be doing. We start off by opening the frames, as mentioned. As you can see, frame equals clip.read does this for us. We then find all the edges using the edge detect function. We crop out the area of interest with the most likely place to find the lanes that we predetermine. And then once we have done this, we find lines using a Huff transform. We then average out these lines, specifically the slopes and y-intercepts of them, to get a singular line that best describes the lane as we feel. And then once we do that, we put those lines over a black background that is the same size as the original image. We then take that and overlay it onto the original image one more time, and we save that finalized video to our out variable, or our out class, I guess. As you can see, we then also display all the different steps so that we can get a general idea of what's going on. And we wait about 16 milliseconds to display all of this so as to get a 60 frames per second video while we're reviewing our code. The edge detection function remains unchanged from class except for the added functionality of removing steps when we need to. The AOI function takes in an image, and depending on whether or not it is part of a larger video or a singular and by itself, it draws a polygon that is then drawn in white so that we can make a mask. Once the hufflines p function is executed, it returns to us two pairs of xy coordinate points that correspond to a single line that we can then use to calculate a slope and an intercept like we would in any other linear equation case. We know that since this video is red with the y-axis going down, that if the slope is negative, which is counterintuitive to how it works in the mathematics world, that it must be a left lane, since those would point up and to the right, which would be negative in this space. And vice versa, we know that if it is positive, it must be on the right side of the lanes. We can then use this to take all those lines and average these slopes and y-intercepts that we receive to get one finalized line for both the right and left side. However, we run into issues if we see a line that is perfectly straight that would result in a zero or infinite slope, and this can cause problems for our later functions. So to avoid this, we simply change all of those into simple points. These pairs of slopes and intercepts are then converted into coordinate point pairs of 4 that can then be converted into lines and then drawn onto the final black background, which will then be merged with the image once more. Over here you can see a video that shows the general idea of exactly how all these steps fit together visually. Unfortunately, this code does not work perfectly, as during the daytime, when shadows are more distinct, it struggles to differentiate between shadows and lane lines, as well as between the different lane lines themselves. To mitigate this, I would probably suggest in the future doing a better job of cropping out the rest of the image, as well as ignoring certain slopes that are of the extreme.